Where they at, Big Mama? Where they at? Hey, aparata. We'll be getting started soon, player. Soon. Just got to get a little few things ready here. Yeah. One more goddamn day when I know what I want. Be consider tonight. Consider tonight. Just another day when all that I want will mark me as a sinner tonight. I'm a sinner tonight, yeah. People can no longer cover their eyes. If this disturbs you, then walk away. You will remember the night you were struck by the sighting. 10,000 fists in the air. 10,000 fists in the air. Oh my God, wow, woo, good job. Thank you guys. Just give me a second. I'm getting things warmed up. This old computer, she doesn't just kick off no more, you know what I'm saying? Give me a sec. I hope everybody's well. I'll get the pleasantries out the way. This is the stream where we do a deep dive into the Swift programming language, and then subsequently we will be doing a deep dive into SwiftUI, which is Apple's latest framework for writing GUIs on all of their platforms: macOS, tvOS, watchOS, iOS, iPadOS. Did I say that? And then after that, we're going to do a little bit of planning, because a matter of fact, my wife-to-be and I are already just formed a business on 420. How about that? A couple of y'all should enjoy that little factoid. But the point is, we're actually building something here. So you're in the right place if you want to learn how to program in Swift. Okay? Okay. Yeah, okay. All right. Now, further to the point, we are beginning with chapter 12 today, functions. Oh, baby, functions. Oh, Nelly. Yeah, just give me a minute. Just relax. Please sit down. Get your writing materials out. Get your Xcode open. If you don't have a Mac, get an iPad. Any iPad. The base iPad. $300. I don't want to hear about it. It's not too expensive. You can do it. You can do it. If you want to code on the iPad, just download a free application from Apple called Playgrounds on the App Store. You can write Swift code, and you'll be able to do anything that we do on the stream in that app. So I don't want to hear no excuses, baby. No, but really, even if you don't have a Mac, the VS Code, if you never heard of it, not Visual Studio Code, don't get them mixed up. Or wait, now I'm mixing it up, damn it. There's Visual Studio, which is the older IDE. That's not what I'm talking about. I'm talking about VS Code, the wildly free and popular text editor with a trillion plugins for nearly everything that Microsoft produces for the masses. So if you don't have a Mac, but you want to write Swift, it actually, even on Windows you can do this. Swift is on Windows. Believe that. Oh, yes. So yeah, you can download VS Code if you don't have a Mac or an iPad, and you can still follow along. How about that? Or maybe if you're a neckbeard brother, y'all are welcome too. Swift works on Linux. So yeah, Sublime, VS Code, Helix, of course NeoVim, regular Vim, even Micro if you like, terminal text editors. All of these things have support for syntax highlighting with Swift, and that's really all that's all you really need, honestly. Because you guys will be following me for the most part, but I do want you to code along to the extent that you can. It's the best thing for you, right? Of course. Give it one more minute. Go get your coffee, get your water, make sure you're hydrating. We're going to take a break, every 30, 45 minutes too. Do some squats. Y'all didn't know it was a fitness channel too, baby. Surprise. You're going to work out too. Surprise. Yeah. They say they want to hold me. They say they want to fold me. They say they want to bold me. They say they want to gold me, shit. But I've been on 2 minutes. Okay, I give up. My rap career lasted for 4 seconds. Better than most. Better than most. 4 more seconds than most. And I take pride in that. You feel me? All right. 3, 2. Wait, hold on. God damn it. Jer, I'm waiting on my producer here to... Jer. What's audio like? We good? Go over there, buddy. Ready for this? Lord have mercy. Now we must get started before 11. That is the official start time. 11 a.m. 11 a.m. She said, call me at 11. Call me at 11. Call me at 11. I said, girl, you were 7. Why would I call you at 11? I ain't calling past 7. Try to make it into heaven. But I ain't. Damn, fucked it up. You know, it was getting there. I might. There might be potential here. I'm not sure. Probably, though. Boom. Jerry, you good? How's that amp over there, buddy? Come on, man. You're going to be here. You're going to work. Come on. Let's go. Yeah, it's fine, guys. Bring it up here. Bring it up here. Oh, yes. Oh, yes. That's what God feel like. It's like, oh. Flex on deck like, oh. Okay, good. You good? All right, good job there, guy. Okay. It's time. It is time. Oh shit, exposed. Shit, I was looking up the lyrics. Sometimes I'll do it off the top, but you know, I don't have to answer y'all. What am I saying? Okay, so if you guys, let's get into learning mode. I think we'll. Oh, who they, brother? Hire me and I will fix your CSS, brother. Oh, there we go. Give us a shout out. If it's not too... Who? Oh, okay. I'll give it 5 stars. I do really like this app. I would say this is the best, I think, well, in terms of how AI can help real developers. Don't get me triggered on this bullshit about AI taking jobs. You fucking think... Anyway, whoa, I digress. Okay, so, who are you? What an interesting thing to say in a questionnaire. Who are you / what are you working on? Who are you working on? It's kind of personal. Myself? What kind of question is that? Suddenly I'm uncomfortable. Yeah, I don't want to answer that question. How has Code Convert helped you save time and effort? Would you... Let's just do this. Spell it right. Code Convert has helped me greatly by showing me quickly. Different implementations as they are represented across different languages. This has been useful for me in selecting the right language with ergonomics that suit my taste. Which it really is great for that, because you can get one implementation of one language, and then of course they don't have every single language, but they do have Swift. But yeah, I mean, it's useful because if you're, once you learn your first language, learning the next one and then the next one will get easier and easier because you'll start to understand the underlying concept. And so really you'll just want to know, okay, how does this language, like what's the syntax? How do I do this? And how do the semantics change, if at all? They're largely the same, but there are some rules, regulations, and stuff like that across different languages. Some are more strict, some are more loosey-goosey, but on the whole, it's not going to take you that long. And so what I like about this tool is it also it's not just a converter, although, its namesake, code convert, but it's also an explainer, which I think for a beginner is wildly useful because you can not only ask, like you go to ChatGPT, I guess you can do it there too, but it's just not as fluid. Sometimes you don't want all the fluff, right? Like when we use it on this stream, there's I shouldn't call it fluff, but it's very verbose, okay? And you don't always necessarily want all of that extra stuff. Sometimes I'm literally just after, a piece of syntax. And, or rather, sometimes I'm also just after a very literal response. Like because even ChatGPT has a tendency to, it tries to speak in natural language, so it can skew the explanation sometimes when you really just want, like, just tell me literally what does it do? Like translate the syntax to language in a very literal fashion. And let me pick out the, bridge the gap. Don't try to pretty it up for me because that can be confusing. So I really like that, the explainer. So you give it code, it explains it. And then on the flip side, it has a generator, so you can just give it natural language and it'll generate code for you. And so it's a great tool. Having those three things together in a single app has been fantastic. And my assumption is that, I don't know this for a fact. You could probably find out. I don't care to because it's been a good tool, so there's no need for me to dig into it. But my assumption is that it uses GPT-4 or either Anthropic, maybe, like some Claude action in the background, because it's always been really good and pretty fast. So yeah, it's a great product. And what's awesome, I don't know if they're still running this, but I snatched up a lifetime deal, $120 for a lifetime deal. That's, that's unheard of in the cloud game. At least these days. I mean, everybody wants you to pay, $5 every 9 hours, like something crazy, but this was very reasonable. And I give them credit for that. So yeah, so I'm happy to shout them out. Okay, so, and then also having the explainer and generator coupled together with the, what was the converter, all-in-one app is a beginner's dream. Great idea. Performance has always been, I'll say, very good as well. I've never come to this site and it's been down, and it's never gave me the old our network traffic is no. But yeah, performance makes me, I feel like I'm almost positive these guys probably have their own server not hitting the API. They probably set up models, like specific models for each language, and just kind of, that's just my guess. But for me to never hit, well, maybe there's not much traffic, but either way, you're still beholden to the overall traffic if you're using the API, so that's why I think that, but whatever, it's neither here nor there. All right, so my name, what do you need my name? My name is James Worthington. How about that? My email. Upload your photo? Goddamn, I mean, I give permission. Oh, because it's a testimonial. I give permission to use this. You know what? I'm putting out this ad, so you guys should go try it, and I'm gonna say that's my. I really don't want to do that. I don't know why, but code convert. I'm giving you some shine. Someone's bound to see this eventually, and so just consider that my contribution. Plus, I'm a paying customer, so you know that too. Okay, I just had to say that so I didn't feel bad. Now, let's get down to brass tacks. Why is there two of these? Wait, where'd I put it? Dapps, apps. So I have my dapps folder, which are developer apps, and then I got caps, which is creative apps. Then I got waps, which is not what y'all are thinking. Don't be nasty. It's writing applications. Okay, and so I'm gonna open up Xcode here. Okay, it's once this opens up, we'll get it popping. We'll get it popping. We'll get popping. It didn't tell us, so we'll probably have to open a new one, but that's okay. We'll open up groceries for now. That's where we were, I do believe. And oh yeah, because I was trying to push my gaming stream on y'all too. And yeah, 12. Okay, sidebar is out. Console's open. Fingers are popped. I got an extra water. Pen and paper. Elbow pads. Or towels. Stress ball. Y'all be stressing me out. Alright, yeah, I think we're ready. Wait. Forgot my good attitude. Jared, give me that. Yeah, rip. No, give me that one. Okay. Functions. A function is named a set of code. A function is a named set of code that is used to accomplish some specific task. The function's name describes the task the function performs. You have already used some functions such as print, which is a function provided to you by Swift. Other functions are created in code you write. Functions execute code. Some functions define arguments that you can use to pass in data to help the function do its work. Some functions return something after they have completed their work. You might think of a function as a little machine. You turn it on and it chugs along doing its work. You can feed it data, and if it is built to do so, it will return a new chunk of data that results from its work. Okay. Functions are an extremely important part of programming. Indeed, a program is mostly a collection of related functions that combine to accomplish some purpose. So, there was a lot to cover in this chapter. Oh boy. Take your time and make sure that you are comfortable with each new concept before moving on. Okay. All right. Well, okay. A basic function. Create a new macOS playground called Functions. All right. I will. File. New playground for macOS. Make it blank. Name it Functions. Tab to my tag. And then Learning tab. Tag. Create. And then I go here and then I hit Control Q and it closes the whole thing. I meant to hit Command W, I think is what I wanted. Okay, good, still had it. All right. Okay, got functions now. Now I bar. Command Shift Y for the console. Go ahead and leave that mug open. All right. And then Vim mode, K to go up. DD to delete the line. I for insert mode. Func. Okay, so our function keyword is func. Func, yeah, brother. Print greeting. Okay. Print. Hello, playground. Is that inside, outside the scope? Okay, print greeting. Okay. Command Shift Enter will run our playground. Once my Mac wakes up. Hello playground equals. I did that. Okay. There we go. All right. Here you define a function with the func keyword, followed by the name of the function print greeting. The parentheses are empty because this function does not take any arguments. More on arguments soon. Arguments have, for a long time, these plagued me because they're used interchangeably, apparently, in some cases with parameters. So you'll hear them referred to as different things often. So just to echo their sentiments from a recent newbie's perspective, just make sure you really understand what you're looking at and understand the terminology. But we'll go, if it gets too confusing, we'll do the normal thing and go on a long-winded tangent to really decipher the English language more so than anything. But it's important. It is important. Okay, so here we define a function. The opening brace. This. Oh yeah. Okay. So this one, the opening squiggle, defines the beginning of our function scope. This is where you write the code that describes how the function will perform its work. When the function is called, the code inside the braces is executed. The print greeting function is fairly simple. You have one line of code that uses print to log the string hello playground to the console. Okay. Finally, you call the function to execute the code inside it. To do this, you enter its name. So here, calling the function execute its code, and hello playground is logged to the console. Now that you have written and executed a simple function, it is time to move on to, why do I have hiccups? To more sophisticated varieties. Function parameters. Here we are. See, we're already, you just said arguments, now it's parameters. Now, are they different in Swift? We will find out. Functions take on more life when they have parameters. A function's parameters name the inputs that the function accepts. And the function takes the data passed to its parameters to execute a task or produce a result. Oh, okay, so now it's coming back to me, so I kind of misspoke, but I just want to say it real quick. They'll probably explain this, but now I remember from the last book that I read, The Secret Life of Programs, that I highly recommend, that I in no way benefit from, but if you want to learn about just general computing, which I highly recommend you do, then yeah, just Google it. The Secret Life of Programs. Great book. Oh, yeah. So when you, let's just say that this is X here. So that would be, since this is where we define the function, meaning where the func word is, because this is similar to a variable, like when we write var x equals something, or if I can get the equal sign, X equals something. So we're declaring a variable. Well, this is how we declare a function. So we're defining the name and also its parameters, which would be x in this case, and then what it does here in the function body. Well, in the definition, so line 3, where we're defining the function initially, these are called parameters inside the parentheses. When we actually run the function, so if you were to print greeting, at this stage, when you actually execute, when you call the function, the value that you put here would be passed to the function's definition. So on line 7 here, x is an argument. On line 3 here, x is a parameter. So it's really just a matter of, is it in the function's definition, or are we talking about a function call? But let's move on, see what they say. Okay, so wait, no, I didn't. Functions, yeah, function parameters. Functions take on more life when they have parameters. A function's parameters name the inputs that the function accepts. Yeah, get rid of those. Names the inputs that the function accepts, and the function takes the data passed to its parameters to execute a task or produce a result. Create a function that prints a more personal greeting by using a parameter. Okay, we can do that. Okay, func print personal greeting. So the first parameter is name of type string. Function body print hello governor. Escape character string interpolation. So pull in the name, whatever we pass to it. Welcome to your playground. Isn't that weird how all that works? It's just computers, man. What will they think of next? All right, print personal greeting name step. Hi, step. What kind of name is that? Step. So I have to, okay, so I have to name it even when I pass it in. Okay, so that works. So hello, step. Welcome to your playground. That's an interesting name. Print personal greeting name string has a single parameter, as indicated in the parentheses directly after the function name. The parameter is called name. Yeah, right here. Right here. And it is an instance of the string type. Yep. You specify the type after the colon that follows the parameter's name, just as you specify the types of variables and constants. Good. Continuity is good. Uniformity is good. When it is called, the function will declare its own new constant called name. We'll declare it. Oh, okay. To store a copy of the value provided by the caller. When you call a function, you include the parameter name and a value of the correct type, called an argument. Hot dog. By the way, although the terms parameter and argument technically have different meanings, people often use them interchangeably. Yeah. These guys, this is a great book. You know, and it's, I don't know if that's irony or not. I don't think that's irony. It's just, I don't know what you would call it. But, you know, it took me a very long time. Granted, I should have just stopped, which is why I'm doing that now. Just stopped and understood the second that I was confused, because this followed me around for a long time. But yeah, just stop and ask questions, because you won't always come across such great, thorough material. Seriously, I mean, I couldn't even tell you. If I had to guess, I would say at least 100 other books before I come across this one, right? And in none of them, when functions are defined, or not defined rather, when they explain to you functions in whatever technology or language that you're learning, none of them did this and made the distinction here, or even cared to explain that out in the wild, people do often, just like I said, and it's true because I experienced it for 10 years. People use them interchangeably, but it's not correct. And so it just helps to really slow down and understand the semantic meaning instead of just kind of being like, yep. Because that's when you make mistakes or get confused or feel lost, and then you're not motivated because you can't really do anything on your own. That's why you need that understanding. Okay, when you call a function, you include a parameter name and a value of the correct type called an argument. By the way, we read that. If you tried to pass an argument of some other type, the compiler would give you an error telling you that the type you passed in was incorrect. Okay, let's do it. Name equals 3. Error. Okay. So we're still getting the type inference, still getting the safety. Good old safety. The compiler in there. This is an example of type safety, the compiler's insistence that all uses of a variable agree on its type. In this case, the argument passed to the parameter name must be an instance of a string. That string value will be interpolated. That string value will be interpolated into the string that is logged to the console. Yes, we see this. We see this in action. Check it out. Your console should say, "Hello, step. Welcome to your playground." And it does. Functions can, and often do, take multiple arguments. Write a new function that does a little math. Oh yeah, brother. This is what I've been waiting for. Oh yes. Write some functions. Okay. God dang, that's a long division. Description for division. I didn't spell that right. Description for division. Description for numerator. So we'll pass it a numerator, and that will be a double, aka a decimal number. I can't remember if a double or a float is bigger. One of them is, they're different sizes, and I forget which, but not important present moment. And okay, so second parameter, we are naming denominator. Also a double. Okay. And we're gonna print escape character, string interpolation, numerator divided by denominator is no, not number formatter. What the numerator? Numerator divided by denominator. Why am I not getting denominator? Wait, numerator divided by denominator is oh, it's all in one. My bad. There we are. Okay, is numerator divided by denominator. Yep. Okay, and division, so we'll pass it 9.0. I like that it does that. If you're confused what it's doing, because it confused me at first, but like when you first go to call the function, you know, so you get the autocomplete, and then we see it right here, and then it shows you the two parameters that we name, numerator, denominator, right? I hit enter, it fills it out, but it's putting the data type, the appropriate data type, but we need to replace that, not leave it there. So we're just going to replace it with whatever value we're passing in. But it's just nice that they do that just because it's showing you, like you know it has to be a decimal number at that point. Oh, 9, sorry, 9. And 3. Command Shift Enter. 9 divided by 3 is 3. Cool. This, well, let me not jinx this. I was gonna say something, but I'm not gonna say it yet. The function division description 4 describes some basic division constructed from the instances of the double type that are supplied to the function's two parameters, numerator and denominator. Note that you did some math within the escape character parentheses of the string. Yeah, that's cool. I don't think that you can, well, let's just go see. I haven't done a Go comparison in a little bit. But I know some languages don't let you nest calculations in your expressions like that. You'd have to do that separately and then just pull it in. But I'm just curious. I just want to do it real quick. So go to the converter, go to Swift, Golang. And if you're curious, I'm not picking on Go. I used to write Go. I wrote a couple of ETL, I don't know what you'd call them, just systems, data pipelines using Go. So, I mean, I like Go. I like Go's tooling a lot, and I love the way that the Go tools function, not like third-party tools, but like the tool chain built into the language is great. So that's why, if you're wondering why I do these comparisons, if I wasn't writing Swift, I would either want to write Go or V, and V is very much like Go, and they openly state that. It just has more niceties, so more or less, I mean, yeah, I want you guys to see it, but it's really more so just for me, just so I can kind of keep a running log in my head of, what it would look like to bounce back and do the same thing in Go effectively. And it's just interesting to see how they, oh, you can do, oh yeah, so Go lets you do it too. But I mean, it's no secret Go's string interpolation is kind of, it's the old school style, so you got to know the sequence. You can't just name it. You see how it's passing it in just from left to right. So numerator is first, so this first %f will take that value. Denominator second, so it's going to come in here. The third result would be the return, or the whatever, you get it. I'm just saying it's nicer in Swift because you can name it. So let me not complain about that, because I would rather have the ability to do this where you name stuff explicitly, and then in your strings you can just call it, and you don't need to be concerned about the left to right sequence, make sure things are passing in correctly, all that. A small nicety, but it's a nice one. So note that you didn't. Yeah, we do see that. 9 divided by 3.0 is 3.0. Okay, parameter names. As you have seen, parameter names are included when you call the function and are available for use within the body of the function. Parameter names are included when you call the function and are available for use within the body of the function. Right. Sometimes it is useful to have different parameter names for these two uses. One name for when you call the function and a different name within the function's body. Sometimes it is useful to have a different parameter names for these two uses. One name for when you call the function, like so. in a different name within the function's body. Okay. I don't know what that means, but we're about to finna find out. A parameter name used only when the function is called. A parameter name used only when the function is called. So in one of these here is known as an external parameter. Interesting. Never heard of it. External parameters can make your functions more readable, provided you choose the names well. It's a big if. I can tell you that oftentimes the me today will not agree, certainly will not praise any names that I picked. You know, the me, or rather I should say, the me tomorrow more than likely is not going to like whatever I called, you know, this. So I wouldn't get too hung up on it. Just be descriptive, you know, but for some reason, maybe this is just a quick aside, but maybe this is something that was prevalent in like a lot of the educational material. I don't know what other reason would contribute to this, but what I noticed. So I'm 34 years old. Okay, I know. I look so young, but across the decade that I was working in and around and with other developers, they were always much older. And, you know, they weren't writing Swift. They were writing things like, you know, Foxbro and like COBOL and Pascal and, yeah, JavaScript or whatever. But the language really doesn't matter. But for whatever reason, they all, because we wrote a lot of greenfield apps, like just from scratch for the most part. And so there was always a healthy amount of design involved. And, I mean, they would just labor over the naming conventions. And I mean, they do matter, and I would agree that it matters more and more the larger your application gets, to an extent. But my point is that you're never going to be able to please everybody, nor are you going to be able to even please your future self, because you're going to constantly, hopefully, be evolving not only your skills, but the program itself, right? It's highly unlikely that you write a customer-facing application that isn't going to see some requests for changes. And, you know, if you're in the business of writing software, you're probably going to make those changes. I'm going to go out on a limb and say you're going to accept that job. And so it's going to keep changing. So for me, what I noticed that I contributed, and actually because I tried a few things. I'm not saying, first idea I had was the best. No, certainly not. But the thing that I contributed that helped us, that actually helped, is using visual tools to convey the structure of the app. You know, because you got folders, directories, and then within them files, source files, all that. Visualizing that and just showing how they relate to each other, that can really help put less burden on the need to have, you know, very granular function names. If you at least understand the structure, so you know that, you know, in this directory or in this bucket or in this module of the app, this is where X, Y, and Z go. You don't need to labor over the naming so much. Anyway, just a quick aside. Just something I noticed. Okay, so then parameter names, have you seen? Okay, so external parameter, that's what they call them. We haven't heard about them. We don't know what they are. And so external parameters can make your functions more readable, provided you choose the names well. Your goal for all parameter names, as for all your code, should be to make them informative and readable. At the moment, the visible parameter name, when you call print personal greeting name, is informative, but not very readable. Okay. You should typically aim for your code to read something. Oh, you should aim for your code to read like something you might say while speaking. That is not possible, buddy, in a lot of it wouldn't even make sense. But you probably would never say something like print personal greeting name step. Agreed. Making your code readable and informative will make it easier to follow. Yes. For example, if a function is going to be used in some other file in your application's code base, and the function's implementation is not immediately visible or intuitive, it could be difficult to infer what values to give to the function's parameters. Indeed. This would make the function less useful, so it can be helpful to use more descriptive external parameter names in your function. Another quick aside, I know for those of you that know a little bit, you're probably thinking, okay, we'll just leave a comment, code comment, right? You can leave whatever above the comment. I agree more with make the code readable. If you rely on comments, you will regret it. If you've ever had to clean up code where the previous developers relied on comments, maybe they didn't regret it, but you regret it for them. You lament their decision. And the reason is, all you're really doing is creating, because again, you're going to be iterating more than likely on this application often. When you leave comments and that's your way of telling other people what the code does, now you're just creating a secondary place that you need to update. So every time you come and refactor your code, when you forget to update those comments, all you've done is now you've just created confusion. So I don't like, and not only that, it's god awful ugly, because naturally people they'll leave 15, 20 lines of comments with their philosophy on, memory man. Like, you don't do that. Please don't do that. It's obnoxious. And yeah, any dev knows you just can't rely on those. You can't rely on them. Just take it with a grain of salt. But yeah, everything should be proved out, especially if you're coming into a new code base. Don't rely on what the comments say. They're very often incorrect or incomplete in terms of the information they're giving you. So just go and try it, see for yourself. Okay, so update print personal greeting name to have an external parameter name that is different from its internal parameter name. Update print personal to have an external name that is different from its internal name, to make calling the function more readable. How? Print personal greeting to name. Print personal. Okay, to name. Okay. To. Let's see what they say, because I hate it. I hate what I'm looking at. Did I add all that though? Yeah, I did. Okay. Now print personal greeting. Yeah, let's do that. Command Shift Enter. Hello step, welcome to your playground. Looks the same. Now print personal greeting to has an external parameter to that you use when you call the function. This parameter helps the function read more like you would speak. Print personal greeting to step. Yeah, no, I hate that. I don't like that at all. But we will learn it. We will learn it. we will learn it. But yeah, if you guys, if we ever end up working together, don't you ever write this in the code. Two-step. Okay. This parameter helps. That it just confuses things to me. I'm sorry. I don't really like that. Yeah. This parameter helps the function read more like you would speak. Oh, we read that. Note that you will use name within the function's definition, meaning inside the scope here, the squiggly. Note that you'll still use name within the function's definition. Name has a clearer meaning within the implementation of the function than to would. It would be a little confusing if your implementation read print hello to. Yeah, it would. I mean, it's the fact that it's even there is confusing. I don't like that. And the fact that you can't use it in the body, definitely don't like that. To me, it should have been like an either or thing. If it was going to be like in the main tool bag, you know what I mean? Otherwise, I'm just kind of thinking, write it off. But I mean, it's nice that it's there. But yeah, I don't know. But there, to me, there's just more value here, because if that's the parameter name, I'd rather know the actual name of the parameter name. I don't want, yeah, that's really not a value to me. Because again, remember that I showed y'all yesterday. Now, this is not a Vim specific thing, but like if we take, how do I, is it YY? Something like that, yeah. So if we, let's just go way down here. Okay, so let's say there's a whole lot of code, right? I don't know where this is at necessarily, like this function. Let me make sure that'll, wait, what's the problem? Print personal greeting. Oh, I got this in there. Name step incorrect. Why? What's the problem? Oh, here. I thought it was the other one. All right, let me get rid of this name. Yeah. So if you're somewhere and you come across this function in Vim, you just hit GD for go to definition of the function, right? And now I'm there. And I can see its definition and the parameters and the types. And so, I mean, for me, it's, I don't know, I'd rather people not go and, because anytime you do like any aliasing or alternates or macros, anything that is allowing you to layer on an abstraction, an unnecessary abstraction over the code, in my personal opinion, I just think that should be a last resort kind of a thing. I mean, goddamn, writing the code's hard enough. You want to add your own specific layer over it? All right, brother, here's what you do when you see this, and now you're going to see this. And brother, why can't you just write the goddamn code? Because then we can just all read the same book or the same specification. Wouldn't that be nice? No, now we got this completely custom implementation. Because Jedediah wanted to get creative over the weekend and rewrite the code base. You see what I'm saying? So just kiss. Keep it simple, stupid. Keep it simple, stupid. Okay, now where were we? You're not stupid. Okay, now print personal greeting. Oh, I gotta undo what I did. To I don't remember all this stuff. 2. And okay, we're back. All right. Now print personal greeting has an external parameter 2 that you use when you call the function print personal greeting. This parameter helps the function read more like you would speak. Note that you still use name within the function, right? Because it would be confusing. Okay, we were there. You may have noticed that there is a preposition at the end of division description 4 and a preposition inside print personal greeting 2. This is not accidental. Prepositions often make function names more readable. God damn it. I hate this Kindle app, brother. If I hadn't spent $300 on that Kindle Oasis, which I love, by the way, it's a nice device, but the Kindle service in general just be pissing me off, brother. I can't even work with my own fucking shit. I bought it. What the fuck? Anyway, I digress. Add positions are a class of, prepositions. The most common add positions are prepositions, those of which precede their complement. Okay. Prepositions often make function names more readable. The Swift naming guidelines suggest that if a function has multiple parameters that formulate a single concept, then the preposition should be placed at the end of the function name. Okay. I mean, really though, who, you hear something like that and it's like, okay, let's leave it wide open for interpretation. That's all that I hear when I read that. Although it's nice that they provide guidelines at all, I suppose, but I'm just saying, this to me is, it's anti-productive because it's so vague. Okay, this is the case with division description 4, numerator, denominator, because two inputs are combined in the division operation. On the other hand, print personal greeting does not have multiple parameters, so the preposition should be placed within the parentheses as an external parameter name. Hold on one sec. I have to go to the restroom. It's about that time. About that time of the day. About that time of the day. BRB. Jared, let's work up a graphic for this. Give me a custom graphic. Yeah. Maybe put some fun eyes on it. Like a fun little, the googly eyes. You do stuff like that? Okay, yeah. Okay, guys, I'll be right back. All right, hold on. Gotta finish my Nutrigrain bar. Don't want to do it in the mic. You know what I'm saying? These are like the crummiest, not like in a bad way, but they create the most crumbs out of any food, other than maybe like a granola bar. I think it's impossible to eat a Nutrigrain bar and spill no crumbs. Absolutely impossible. Yole. Hey Jay, how the first 20 coming up? Hot dog. Zooby zooby zoo. Zooby zooby zoo. Zooby zooby zoo. All right. Now that I've can't even talk. Now that I've been synthetically enhanced, I can we can get back to it. Yep. Okay. Toilet time is over. It's over. It's over. Default parameter values. All of a function's parameters must be provided with a value when the function is called. As the caller, you provide values by passing in arguments. As the caller, you provide values here. So, caller, values that we provide. Okay. Swift's parameters can also take default values. Okay. If a parameter has a default value, you can omit that argument when calling the function. Oh, cool. In which case, as you might expect, the function will use the parameter's default value. I like that. I like that a lot. Hot dog. Okay, go ahead and add one to your division function. Note that we have broken the call to print across 2 lines to make it fit on the page. You should enter it on 1 line. Oh, I see. Is that okay? See, I wish... I'm not going to complain. There's nothing to complain about. It's fine. I just want to get the code example on 1 page. Then I can make it big again. Okay, there we go. What do you want me to do? Funk, personal greeting. Oh. Personal greeting. To name, string. Name string. Wait, we did that. What do you mean? It's right there. Two-step. Okay. Oh, when I made it smaller, it... Okay, my bad. We're here. Alright, that was weird. I was like, what the hell? Okay. Go ahead and add one to your division function. Note that we have broken the call to printer. Okay. Now we're in the right spot. Func division description. So you want me to get rid of the old one entirely? Print. Yeah, okay. I just want to make sure that was just one. Alright, so func division description for, and then our first parameter is numerator of type double, denominator, and it's a double, with punctuation, with punctuation. With punctuation. Oh, that's our external. This is an example of that external parameter. Okay. Cool, so you can mix and match them. I like that. I mean, that part is handy, so that's cool. Ooh, you know. Yeah, actually, so I didn't tell you guys, but so, you know what? I'm gonna write it down. I'm gonna tell you at the end, because it'll go for a while. So yeah, let's just keep learning. Jared, remind me before we cut off, eh? Jared, can you? Okay. Where were we? Punctuation. Oh yeah, we're writing the function with punctuation, so we have an example here of an external parameter, punctuation. And I was just giving it praise for the fact that you can mix and match and string and then equal. Oh wait, that's new. We haven't seen. Oh, that's a default value. Oh, okay. So when you define a function. Okay, yeah, I mean, that makes a lot of sense. So right where you define the parameters, numerator, denominator, and punctuation, if there is a default value, then you can just throw it in there with an assignment operator. Cool. I thought we'd have to do something in the body. I like that. Pretty neat. All right, so okay, so I got that, and then we open up the function body scope, and what you want in there, cousin? All right, print escape character, print the numerator divided by escape character denominator is numerator denominator. Oh, okay. So then we escape it. We give it this expression, numerator divided by denominator. It would do that math. And then since it's at the end of a sentence, there's no space, another escape character, and then punctuation. Since that's the default value that we want, which is equal to this period here. And taking note, as they told us, that when you're inside the function scope, so inside the squiggles, we still have to use the actual parameter name and not the external parameter name. ¿Tú sabes? Okay, great. Division, description. They didn't mark that out, so division 9.0. And now that we're creating a caller for the function. Oh, I didn't spell it right. Did I? Descriptoin. Oh, when I rewrote it, I fucked it up because the other one was already there. Okay, not Descriptoin. No, that's not correct. Okay, description for. There we go. Now we got my cool colors and stuff. Okay, so now I want to. Oh, and it made me. By now. All right, numerator is still 9. If I tap, oh my god, yes. I love shit like that. I don't know how to illustrate. Well, actually, I do know how because y'all can see my key. Whenever I have, whenever I'm pressing special keys like modifier key or tab or space or alt or delete, not regular characters, but you'll see it in the bottom right hand corner. I don't know if y'all noticed that or not, but yeah, that's why that's there. It's to help me, and I think it would help, if not at least, or wait, what am I trying to say? I think it'd be a benefit, and I don't think it impedes anything, so I just want to leave it there for now. Also, I modify my keyboard a lot. I'll just kind of play around with different configurations, and so it helps me to remember, because sometimes I forget where I actually put, or what keys I actually map to what. So two birds. Okay, I want to put 3.0 here as well. And then here's our external. So we're inside the caller now. So now we're allowed to use our external parameter name with punctuation. Oh, I see. So if there's a default, but if you want to override it, you can. But if you notice, when we first call the function, like if let me type it again. Division. So when I first call it, you see in the line here, numerator, denominator, it's not listing punctuation because it has, well, I'm assuming because it has a default. But I bet Vinaigrette that if I take this away, I bet it'll show up. Oh man, what can I say? I just regular old sleuth. Okay, so that means that I want to wait. Let me just Control Z that bad boy. Okay, yeah, so that's cool, and that makes sense because if you give it a default, then we can make the reasonable assumption, and this is how the compiler is treating it. We make the reasonable assumption that by the author, us, choosing to give a default value to a parameter of a function, it's effectively saying that the majority of the time you would like for it to use that value. And so by default, when you call the function in your IDE, just as a nicety, it's not giving you the, it's only showing the two parameters that do not have a default. So it assumes you want to use the default. But if you need to change it, you can, which is what we did here. Okay. Now that I've expressed my thoughts, now what do they, Command, Shift, Enter. Yep. Okay. Now the function has 3 parameters: division, description, numerator, denominator, and with punctuation. Notice the new code punctuation string equal period. You add a new parameter for punctuation, including its expected type, and also give it a default value via the assignment dot string syntax. This means that the string created by the function will conclude with a period by default. Your two function calls illustrate how the default value works. Your two function calls, yeah. To use the default, as in your first function call, you can simply omit the final parameter. So talking about this one, we just leave it out entirely, which is valid because the third has a default value. Or, as in your second function call, so line 21, you can substitute a new punctuation mark, or technically anything, right? Any string, not just a punctuation mark, for the default value by passing in a new argument. So it could have been bleh. And that works too. Just saying, I know maybe not everyone is quite so literal as I, but I like to point these things out because it matters. And it would always trip me out. Like, how does it know what a punctuation character is? Does it just know that? Like, that's built into the language? It knows, like, literally that certain characters are punctuation? No, it does not. It has no concept of punctuation as we understand it. The only grammar that it adheres to is all the shit that we're learning, but it ain't English grammar. Can you imagine if English was a programming language? That would actually be the most complicated programming language ever. That would be a nightmare. Okay. Your two function calls. No, read that. First, second. Oh, we were at the end. Okay. And what are you showing? They're showing exactly what we got. Okay, so we don't need to necessarily be too concerned with what's in that figure. In-out parameters. Sometimes there is a reason to have fun. Jared, edit that in post, will you? Thank you. In-out parameters. Sometimes there is a reason to have a function modify the value of an argument. Sometimes there is a reason. There's a reason. Sometimes there is a reason to have a function modify the value of an argument. To modify the value of an argument. Oh, yeah, sure. Okay. Yeah, like maybe if you wanted to let the user, because this is something that we will build, like a lot of these, we spoke a lot about MRP. I won't do that to you again. I might tomorrow, but I'm gonna let you off the hook today. So if you don't know what MRP is, don't worry, we will be talking about it again. But in terms of the applicability here, if you wanted to say do like what do you call it? Scientific notation, like if you wanted to allow people to, or not scientific notation, not the little one, the exponents, 3 to the power of whatever, that kind of stuff. I can see that applying here. So you let the user give you the multiple, or the exponent rather, and then perhaps they want to see some, like let's say they run a report on sales, blah, 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 and you want your tool to allow them to see effectively a forecast or a what if. And so they could say, okay, this is my revenue for 2023. If I want to make, let's say you want to grow 3%. Pretty aggressive, but it's possible, certainly. And you want to know, if we do grow 3%, what is going to be our annual revenue, at the end of the year, or at the end of Q3. So, just different scalars, a way to work off what's already there. And then you let the business person just have a sandbox with their data. Pretty straightforward, but I can see how this would apply. So that's cool. Okay, so say you have a function that will take an error message as an argument and will append some information based on certain conditions. Okay, that's a very different use case, but okay, I'm listening. Say you have a function that will take an error message as an argument and will append some information based on certain conditions. Okay, enter this code into your playground. Var error. The request failed. Error code. Wildcard code. I'm glad we're doing this, because I keep seeing that everywhere, that underbar. I mean, I know it's a wildcard, but I don't know that that's what it means in the context of the syntax here. So finally we will understand. This will actually help me make a lot more sense of a lot of the docs, because I see it everywhere. Okay, to error string, yes. So that would be an external parameter, the to error string, and oh, weird, in out, a new type, in out. Okay, string. Then we open the function body, if code, equality operator. So, oh, I see what's going to happen here. So if the error code is equal to 400, so if that evaluates to true, then it'll take the error string, or the error message, and append bad request. And then append error code. So then we are making a caller for this function. It gives us parameters and types from our definition right above. And they're giving it 400. And that makes sense because it's an integer. So that'll be valid. And then to error string and error. I wonder what that ampersand, what that be? Okay, so then, yeah, okay, then we print the error. Whoa, brother, why'd you do that? Freaking thing. Xcode does some wonky stuff sometimes. Sometimes it'll, I mean, you probably can't tell just watching, but it'll not freeze, but I don't know, everything, just like mid typing, everything's normal, and then it'll stop input for just a sec and then like spit it all out and catch you back up. It's really odd. Don't like that, but hey. Okay, print error. And this is an M2 MacBook Pro with the second largest chip. Like, I just don't understand why it's slow. Why the fuck is it slow, and why the fuck did I spend that kind of money on this computer if it's gonna... I got 30 lines of code. I digress. Okay, so okay, let's just see if it's valid first. Cool. The request failed. Bad request. And we only got that because the if statement here. But if this was not 400, what happens? The request failed. No extra info. Not yet, but we could add it. Okay, cool. So the function append error code has two parameters. The first is the error code that the function will compare against, which expects an instance of int, which is right here. Notice that you gave this parameter an external name of, oh, so it can be anything, which has a special meaning in Swift. Using underbar in front of a parameter name will suppress the external name when calling the function. Oh. Will suppress the external name. Okay. Because its name is already at the end of the function name, because its name, oh, code, the word code, because its name is already at the end of the function name, there is no reason for the parameter name to be used in the call. So because we named it this way, they're asserting that there's no reason to have to write it out like so. So we don't have to do that. I mean, again, I mean, maybe it's just me. I don't know. I don't like that. I don't like cute shit like that. I don't like that. I'm jaded. I'm sure I'm jaded though. I had to deal, y'all have to understand. Y'all know how many stored procedures I had to rewrite. And you see shit like this, people getting all cute with references here all over the place. But they're teaching us, so we should be grateful. I should be great. I'm grateful. But yeah, I don't like that style. I just like for it to be explicit, but that's okay. Okay, so they're saying this is shorthand. So this is a ergonomic feature. Name to error. This second. Wait. There's no reason. Okay, so the second is an in-out parameter. Yeah, what does that do? Because that's interesting. So we saw that here. Denoted by the in-out keyword named toErrorString. This parameter expects an instance of string. We know that because of here as its argument. ToErrorString here. Let me make that little there. ToErrorString. Yeah. The in-out keyword is added prior to string. Wait, no, I skipped something. The second is an in-out parameter denoted by the in-out keyword named toErrorString. This parameter expects an instance of string as its argument. ToErrorString is an external parameter name used when calling the function, while errorString is an internal parameter name used within the function. Yeah. The in-out keyword is added prior to string to express that the function expects to modify the original value. Ah, okay. So in-out if we need to modify any of the arguments. So in out string. So that's not, or I don't know, is that a type? Maybe it is a type. But either way, it goes ahead of string, just like we got it here. Okay, so that says, yeah, okay, so in out, yeah. Okay. That I like, that's cool. The in out keyword is added prior to string to express that the function expects to modify the original value. It does this by taking as its argument. Wait, what? It does this by taking as its argument not a copy of the passed in value, but a reference to the original. Okay. It does this by taking, comma, as its argument, dash, not a copy of the passed in value, comma, but a reference to the original. Okay. This way, any changes it makes to the string affect the original string, and those changes will remain after the function is done executing. Okay, let's read out. That's not what I thought they were saying at first. So, okay, maybe I have the use case janked up here. So, okay, the in out. I get that part, but are they saying it's going to... What do you mean go back and update it? Not a copy of the passed in value, but a reference to the original. I guess it just depends, because the input could just be from standard in from the user. So what are you going back to update? You know what I mean? What do you mean? Yeah, so let's read on. So this way, changes it makes to the string affects the original string, and those changes will remain after the function is done executing. Yeah, that's odd. But I guess if it was anything other than standard in and you were just pulling in some other data value, like the date or the system time or something, I don't know. When you call the function, the variable you pass into the in-out parameter must be preceded by an ampersand to acknowledge that you are providing shared access to your variable. I see, so that's what that means. Here on line 31, when you call the function, the variable you pass into the in-out must be preceded by the ampersand to acknowledge that you are providing shared access to your variable instead of just a copy of it, and that you understand that the variable's value may be directly modified by the function. Why do I feel like I'm signing my life away when I read that? Here, the function modifies error string to read the request failed, bad request, which you should see printed to the console. I do. Note that in-out parameters cannot have default values. Okay. Also, in-out parameters are not the same as a function returning a value. Yeah, this is weird. Lastly, because in-out parameters grant shared access to a variable, you cannot pass a constant or literal value. Okay. If you want your function to produce something, there is a more elegant way to accomplish that goal. Okay, so if you can't pass it a constant, so anything that you define with let, you would not be able to use with in-out, and any literal value, as in like 3 or something. So just mutable variables. So that answers my question, because I guess if it was standard in, okay, so you can't use it with that. So that answers that. Okay, at least it makes sense. So note that In-out parameters cannot have default values. Note that in-out parameters cannot have. Okay, right. Yeah. Cannot pass. Well, I just want to be sure. What? No. Swift. Why is it examples of? You can't see it, but I'm typing print examples of literal values. Yeah, like any of your primitives, so you couldn't, yeah, okay. Yeah, so that's right then. So only applicable to anything defined with var, basically, like this. Okay, so next, returning from a function. Functions can give you information after they finish executing the code from inside their implementation. Okay, this information is called the return of the function, return of Jafar. In fact, this is often the purpose of a function. Agree? To do some work and return some data. Make your division description for function, return an instance of the string type. Return an instance of the string type instead of simply printing a string to the console. Return an instance. Okay. So get rid of what? What do you want me to do? What do you want me to do? Print. Oh. Well, that's nice and handy. Just a nice little keyword, return. Makes sense. Oh, and we no longer need end of the line, $. Capital A, insert mode, end of the line. Get rid of that. Okay, so we don't need the parentheses. But we need a space, though. God damn it. Return. What's the problem? That's what they have. Is it? Func division description. Oh, I didn't. My bad. You gotta add the return type ahead of the function body with this arrow operator. Yeah. Okay, so func, the function name, the parameters, and then if it is returning something, you would give it this arrow syntax and then the type that it will return. So string here would be, you're saying that this will result in a string. That's what you want the function to get back. I like that. I mean, I like the arrow because it's pretty good, straightforward description of what's happening. Okay, so does that work? Command Shift Enter. Okay. Oh, it's okay. So we did the same thing, but we didn't print. We returned it. What's the difference? The behavior of this new function is very similar to your earlier implementation with an important twist. This new implementation returns a value to the code that called it. This new implementation returns a value to the code that called it. This return value is denoted by the arrow syntax at the end of the function signature. Oh, okay, so that's another term that would be handy to lock down. So this that right there is the function signature. Well, actually, it might be just that. I'm not sure. But it's describing certainly the name of the function and its arguments. So arrow syntax after the function signature to denote the return type. Okay. Your function returns an instance of the string type. The return keyword tells the program, stop executing this function and resume the calling code where it left off. What else would it? Okay, well, we'll just keep going. If there is a value to the right of the return keyword, that value will be handled. That value will be handed back to the calling code. So in this case, this singular string is our value. That value will be handed back to the calling code. The type of this value must be the same as the declared return type of the function. Okay. Wow, okay. All right. So they're saying that the result of whatever is after your return keyword, so in this case, this literal string, since it's a string, we know it's a type string coming back. And so when it comes back, it's going to circle back around and check what you put here after the arrow ahead of the function body, and these need to agree. So the value of this would have to be a string in order for it to be valid, and in this case it would be, because we're saying it'll return a string. Interesting. Okay. Okay. See, these guys are great. I mean, no one explains it like that. Well, maybe somebody, but I had not come across it. And now I have. Cool, so I'm gonna keep that with me in the old noggin. So then the return keyword stuff. Okay. When there is no value to return to the caller, a function will implicitly return at the end of its scope. And what they mean by that is at the closing curly brace that ends the function body. Right. So here on 17. This is why your previous functions have not needed to explicitly return so far. Oh, because there's no return value. Okay. You will learn more about implicit and explicit returns from functions in the next chapter. Great YouTube channel, by the way. If you like basketball, look up the next chapter. It's pretty cool. Because your division description for function no longer contains a call to print, your calls to it no longer produce console output. I thought it did. Oh, it's the one below it. That's why. Okay. Yeah. Calls to it no longer produce console output. But it returns a string and print accepts string arguments. So you can call your division function nested within a call to print. Oh. Within a call to print to log the string instance of the console. Oh, okay, they literally just wrapped it up. Print. No. That is a lot of thunder I hear. Print. That is so annoying that you can't. How can I? When it line wraps like that, it's pretty annoying because I can't just go to the next line. Insert. Closey thingy. Print. Oh my god, that's. I guess I could do $. Yeah. A. Okay, that's not that bad. So now we do get those printed. I see down here. Okay. Nesting function calls. When one function call is nested within another like this, they are executed from the innermost function to the outermost. Algebra, baby. In this case, division description for function will be executed by the program first, and then its string return value will be passed as the argument to print. Yeah. It makes sense to me. Nested function, definitions, and scope. Oh boy. Hot bibbity bob. Man, it's a lot of clouds out. Hold on one sec. If y'all have never tried, like if you, I'm just talking here, I'm just filling the air. If, as a secondary kind of interest, if you just want to check out other languages that are heavy on the functions, meaning like if you think mathematically, I think something like Clojure you probably would like. It's an interesting language because there's very little syntax. It's almost all functions, but the downside is you just have like a lot of parentheses, and I mean a lot. Like to get anything done in a function, you're gonna have all of these other little nested functions. So it can look pretty crazy, but it's a great language for like data-oriented tasks, stuff like that. And it's dynamic, so it's not super fast, but that's okay if it's for not a giant application. I don't know. I mean, gauge it for yourself, right? But oftentimes it's totally fine for something, especially just for learning, and you can always optimize. So yeah, you should check it out if you like super straightforward, simple syntax. Yeah, Clojure. This is not to deter anybody, obviously, because I brought it up, but it runs on the JVM. I had certain feelings. It's a good platform. You shouldn't think less of it. It's just a personal thing. But yeah, it's a JVM language, so Java libraries and the Java runtime are available to you. Well, the JVM is a requirement. You can choose to use the libraries, but whether that's a good or a bad thing to you depends on you. So, why is this? Okay. Nested function definitions and scope. Swift's function definitions can also be nested. Swift's function definition. Nested functions are declared and implemented within the definition of another scope, of another function. Nested functions are declared and implemented within the definition of another function. Sure. The nested function is not available outside the enclosing function. This feature is useful when you need a function to do some work, but only within another function. Let's look at an example. Okay. GG. Oh, GG. There we go. Oh wait, I went to the top. I want to go to the bottom. Capital G. There we go. Func. Area of triangle width. Base, and that'll be a double, and height, a double. And where the there it is. Our return type. So we're saying that whatever the return, or whatever the value is after the return in the body of our function, the type of that value should be a double. And if it's not, fail. So let rectangle equal base times height. And then another nested function, only available within the scope of the squiggles. Divide. And again, our return type, why can't I find my dash, is a double again. And the scope of this nested function is a return rectangle. So give us back the base times the height divided by 2. And then, so that's within the scope of the nested function. Now we're back in the scope of the area of triangle width function, and we want to return the value that divide produces. Yeah, brother. Print area of train. Yeah. 3.0. Then I can just hit tab. Love that feature. 5.0. Command Shift Enter. Hot dog. Yeah, cool. Yeah, and that's a very, I mean, that's a lot of things just opened up for me. I don't even know. I mean, functions like this, just nested functions, doing math, giving math back, stuff like that. I mean, that's going to be 40% of the code probably. Yeah. Very cool. Okay, I like that. I mean, that's very easy to reason about, I believe. The function area of triangle width takes 2 arguments of type double. Of type double. Base and height. Oh, I can't tell if what's syntax or not sometimes, but that's okay. Okay, so we get it. So yeah, that's what they are. We can see the function definition ourselves. So it also returns a double. Inside this function's implementation, you declare and implement another function called divide. Right here, 36, line 36. This function takes no arguments and returns a double, as noted here, specifically, or rather here, specifically. And wait, where are we? Takes no arguments. This function takes no arguments and returns a double. The area, the divide function above uses a constant called rectangle, which is here, and defined here. Constant call, rectangle that is defined in area of triangle. Yep. Why does this work? Anything within a function's braces, i.e. the scope, is said to be enclosed by that function's scope. In this case, both the rectangle constant and the divide function are enclosed by the scope of the area of triangle width. Yes, they are. So area of triangle width, the scope begins at the end of line 34, where my cursor is, and then ends on 40. So everything inside of it, that's the function body, aka the scope of this function. Same is true here for func divide. The scope for this is right there. Okay, we understand this. Anything within a function's braces is said to be enclosed by the function scope. In this case, both the rectangle constant and the divide function are enclosed by the scope of area of triangle width. A function scope describes the visibility of an instance or function. A function scope describes the visibility an instance or function will have. Okay. Right. In terms of boundaries represented by the squiggles. It is a sort of horizon. Anything defined within a function's scope will be visible to that function. Anything that is not is past the function's field of vision. Rectangle is visible to the divide function because they share the same enclosing scope. Why do I have the hiccups? Rectangle was... Right, sure. Between, end of 34 and 40. So here's rectangle, here's divide. Therefore, I can return divide. On the other hand, because the divide function is defined within the area of triangle width function scope, it is not visible outside of it. Right, so here. So here I wouldn't be able to reference rectangle or divide. Wait, no, that's not right. What am I saying? Func divide. Oh no, that is right, because I returned rectangle and I'm using rectangle. Yeah. Okay, so by the way, nearly any pair of braces in Swift defines a scope. For example, switches, loops, and conditionals define scopes of their own. Right. Outside of the enclosing function. Wait, what? The compiler will give you an error if you try to call divide outside of the closing function. Oh, yeah, outside the closing function. Yep. Confirmed. By the way, nearly any... Oh, no, we read that. Divide is a very simple function. Indeed, area of triangle width could achieve the same result without it. You could just return... Oh, yeah, I see. Just return and do the math yourself instead of defining rectangle. Yeah. The important point here is how scope works. You will see a more sophisticated example of nested functions in chapter 13. Stay tuned. 13 sounds like a biggin. It sounds like a biggin. It just does. Multiple returns. Ooh, boy. Functions can only return one value, but they can pretend to return more than one value. Go on. To do this, a function can return an instance of the tuple data type to encapsulate multiple values into one. Oh, pretty tricky. Recall that a tuple is an ordered list of related values. Ordered list of related values. To better understand how to use tuples, write a function that takes an array of integers and sorts it into arrays for even and odd integers. Oh, wow. Okay. Func. Sorted, even, odd numbers. Wildcard numbers. Why did, oh yeah, okay, I remember now. This thingamabob. Let's just do what this is doing up here, because the name of it is already in the function definition, I recall now. Okay, so numbers, int, so array of integers, and then a return type, evens. What? Int odds. Oh, okay, so return a tuple, evens and odds. Evens and odd. Then we open the function scope. Var evens is equal to an array of integers. So I initialize, right? I initialize an empty array of integers for evens, and then var odds. Same thing. Okay. For number and numbers. So that's we're starting our for loop. So number is our iterator. In numbers, if number mod, so divide a by b, whatever the remainder is what that mod operator gives you. So if number two oh, I see. So this is saying if number, which would come from that array of numbers we expect, if dividing that number by 2, if it's divisible by 2, then number mod 2 would equal 0. It's saying the same thing. I'm not explaining it well, but you understand. So if you divide number by 2, is there any remaining value, or is it divisible by 2? So 10, 4, 8, 20, 30, even numbers. Okay, so that's how we're saying that. I'm saying that more to myself, not to the my non-audience or the future self. Yeah. Evens, I can easily I'll get my brain in a noodle knot, as I call it. Okay, evens.append see what's happening here. Or do I? Evens, not a pin number. So we just, oh, I see. So we're creating a method to basically break out these number groups into even odds coming from a single array. Odds append number. Boom, boom. And then finally our return value. So give me back evens, odds, because now they're split up, and or rather this, whatever this evaluates to, evens, odds, I'm saying here it needs to be compatible with this type, and it would be. So evens, odds, as long as they're integers, then we're good. And they would be, because we said so here. Command shift enter. I guess I didn't print it anywhere. Here, let's just see what they Here you first declare a function called sorted even odd numbers. You specify this function to take an array of integers as its only argument. You specify this function to take an array of integers as its only argument. Oh, yeah, here. Okay. Oh, because that's the return type. I see. So it's just this. Okay, my bad. All right, I'm with you. You specify this function to take an array of integers as its only argument. The function returns a named tuple. That's where we're at. So now the return type, evens, will be an array of integers. Odds will be an array of integers. The function returns a named tuple, so called because its constituent parts are named evens, or named evens will be an array of integers, and odds will also be an array of integers. Yeah. Next, inside the implementation of the function, you initialize the evens and odds arrays here. So we initialize empty, hence the funny looking syntax there. And we have to do that, otherwise we couldn't use them in the subsequent for loop here. So each time we call the function, we initialize these over again inside the scope of the function. And where'd I go? Next, inside the implementation, yeah, you initialize the evens and odds arrays to prepare them to store their respective integers. You then loop through the array here. You then loop through the array of integers provided to the function's parameters, numbers, here. And at each iteration through the loop, you use the modulo operator to see whether number is even, which is this check here. I feel like somebody might want to see that. So 2 mod, or no wait, I would do 10 mod 2. Like that should be 0, but 11 mod 2 will not be 0. It's 1. Why is it 1? Because you take 10 from 11 and get the remainder. So you can almost think of it like divide A, 11, by B, 2, as many times as you can, up until the point where it can no longer be evenly divided by. So in this case, that upper limit would be 10. And then you just take the remainder. So whatever the remainder is, is our answer. So 11 less 10 is 1. Hot dog. Okay. So that's the check. Because any number divisible by 2 is going to be mod 0. Or there's going to be a same result. So that's how we know. Okay, and then at each iteration through the loop, you use the mod operator to see whether the number is even. If the result is even, if it's even, you append it here to evens. So evens being our variable, and then dot notation method call append number, which is our iterator, and it's going to do it each time. Boop, 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 boop. Okay, we understand this. Now that your function is set up, call it and pass it an array of integers. As usual, do not break the string. As usual, do not break the string passed to print in your code. As usual, do not break. What do you mean? Return evens odds. Okay, so let a bunch of numbers equal 10, 1, 4, 3, 50, oops, 3, 50, 57, 43, 84, 84, 27, 27, 1, 5, 6, 1, 1, 1. Oops, 1, 1, 1. Okay, let the sorted numbers equal sorted oh, that's cool. It's handy. A bunch of numbers. Print the even numbers are escape character, string interpolate the sorted numbers dot even dot evens oh, so that's just a where did that come from? Sorted. Oh no, duh, we just wrote that. Okay, my fault. Yeah, so we're just giving it, we're creating data basically. Okay, so, and the print statement. All right, so a bunch of numbers, and then the dot evens. The odd numbers are escape character, string interpolation. The sorted numbers dot odds. And we can do this because it's available outside the scope of the function, because that is our return value there. So evens here, we can call it here and here, and we're processing these numbers. So we should see those broken out correctly in our print statement. Command Shift Enter. Hot dog. The even numbers are 10, 4, 84, 156. The odd numbers are 1, 3, 57, 43, 27, 1, 1, 1. 111. Okay. OCD squash, baby. Okay, so that's cool. I mean, that makes... it resonates with me. I feel like... If you say that out in real life, at your job, I feel like okay, optional return types. Sometimes you want a function to return an optional. Sometimes you want where are we at? They weren't kidding. This is a long chapter. So I think we're gonna chop it there because we're approaching 2.5, and we've actually, I feel like for the most part, stayed on task. Definitely more so today than yesterday, and so that's, yeah, I think this will be a good. Let me see how many pages are left before, or how many concepts, I guess I should say. God damn. Oh no, that's perfect. Okay, so 2 and 3, 2 or 3. Yeah, so we'll pick it up on page 247 tomorrow. Thank you for watching. This concludes episode 12 of the Swift and SwiftUI Learn Along, Big Nerd style, and my style. Now, as always, please do drop a sub, drop a like, donate, send money orders, wire cash, okay, pledge, Amber Heard style. Go ahead and pledge 700,000. Or how much was she supposed to? 5 million. Ooh, she's a liar. Okay, anyway, I digress. She's got enough of that. So I just been watching it on YouTube. That is absolute gold. You could not write a better script, and it's incredible that that's a real story and we all got to witness it. I think a lot of good lessons are in there, seriously, to be learned. So if you've not seen that whole Amber Heard, Johnny Depp, the whole thing is, it's on YouTube. The original, I would just watch the original. It's honestly entertaining enough without having to, unless you just have a streamer that you like to watch and listen to on top of other videos. But yeah, check that out if you need some entertainment. Thank you guys for watching. We're going to be back tomorrow. We'll be on tomorrow for episode 13. Make sure you follow. And again, if you like Halo or shooters, or if you just like me and you want to see me play video games as well, right now I am running these 2 streams. So this, of course, is one of them. And then from 9 o'clock to 11 p.m., I'm running 100 days of ranked Halo. Okay. Whooping ass, and I think today is day 35. Yeah, so come check it out. But yeah, other than that, guys, have a good day. Be productive. Make good choices. Don't let people punk you. Okay, stand up for yourself. Don't be a bully. Don't be petty. And most importantly of all, be good to one another. Good day to you.